Hi, everybody. Welcome to the Chapter 6 lecture notes on floods and flooding. This is going to be sections 1 and 2. So we're going to go through Chapter 6, Section 2 in this set of video notes. So I'm starting a few slides in. As you know, the slides that I give you in class, the first couple are the chapter objectives. And so I'm going to be starting about on the 4th or 5th slide. Talking about kind of a case study that we're going to be mentioning, and that is a major flood event that took place in Pakistan in 2010. About 12 inches of rain fell over the course of one day, or 24 hours in July 2010, and that's a tremendous amount of rain. I mean, we think about a couple inches per day as being a lot. 12 inches is a heck of a lot of rain, and so that rain's all got to go somewhere, and it flowed out the Indus River Valley. Now, the Indus River is one of the main rivers in Pakistan, and I just want to show you a picture or two from before and after. So, right here, there we go, is the country of Pakistan, and the Indus River. You can see there's kind of that green swath that goes through it. All right, so we've got, if you look right here, you've got some kind of looks like somewhat dry river valleys. I can't zoom in too terribly close, but take a good look at that. All right, and see that green swath right there, and some of the actual paths in the middle right there are kind of dry looking. But now look at it after the flood, or I should say during the flood that took place. And you can see that it's the same green area, but the channels where the river actually flowed, especially here and here. Now keep in mind, these are satellite pictures. You can see this water from space. I mean, this is a very wide bodies of water that are flowing in what is normally just a regular river valley. So there was a lot of water that fell and really spread out and covered a lot. Let me go back a little bit. What was it? 5,500 square kilometers of water. That's a lot. A tremendous amount of area, and I think that I had read that about 1/5 of the entire country was somehow affected by water. So there were warnings that were put out beforehand, and even so, people weren't really able to. They may have been able to, but many people just did not heed the warnings, and therefore were really affected by the water. One of the things that did happen, one of the many things that did happen, was the fact that there was a lot of disease that took place because you have all this water and there's really no fresh water anymore because the water is covering everything and getting contaminated. So disease spread very rapidly, even in like health camps where it was supposed to be a little bit safer. So a big event in 2010. So before we understand floods, we really need to understand about how rivers themselves work. Now, rivers are basically pretty easy to understand. Water flows downhill. That's basically it. Right? It flows downhill under the influence of gravity. All right, and so as they fill up channels, that is grooves in the ground, or sometimes even the flowing water makes grooves in the ground, we call that a river. And different parts of it are, different parts of the river have different names depending on how big or wide the channel is. For example, we have streams. Now we're going to use the word stream to describe pretty much anything that flows through a channel on the land, but or at least USGS geologists do that. But streams are actually kind of small bodies of water that flow together, all right? And then tributaries. Think of it like this. A tributary has the word tribute in it, or like they contribute to a larger body, all right? So actually, I know the word tribute is its own word, but yeah, they contribute. So that wider one right there is a tributary, and so here's another tributary from somewhere else that has streams coming off of it, and they contribute to an even larger stream, which that's like I said, the generic word, but we would call that a river. All right, so as the water flows off the land, it flows into these channels and goes downstream, which brings us to the idea of a drainage basin. What a drainage basin is an area. So say, let's see, I'll draw this in red right here. It's an area on the ground where every single drop of water that falls into that area, and in the form of rain, winds up coming out of some sort of river out the end. So all these streams and tributaries right here are, you might say, in the same drainage basin. We sometimes call that a watershed. All right, as the land sheds the water, it all runs down and right out the bottom of the main river right there. All right, so places like this, where you have like the red dotted line, what would probably exist at the red dotted line right there? Ooh, I'm drawing in blue, sorry. Well, we probably have some sort of a high point, right? Or a high mountain range or hill or something like that, because everything inside that, runs out of our river. Everything outside of that runs off to, well, some other river basin. Okay, so usually the edges of drainage basins or watersheds are some sort of high point or ridge or some sort of continental divide. I'll try to pick it up a little bit right here. All right, so the as the river moves downstream, it moves downhill, of course, and the hills are, we know, sloped. But we give that a name, and we call it the gradient. All right, now, gradient is how something changes over time. You may have a color gradient where a red kind of fades into blue, which fades into green. Well, you can, if you have a stream gradient, it really just means how the height changes over time. All right, so say we have a mountaintop right here. Okay, well, the gradient is changing. We've got a really steep gradient there, a less steep gradient right here. All right, so at high elevations, it's very, very steep, and so water's going to rush down very rapidly right here. At lower elevations, it's not quite as steep, and so the water's going to sort of fizzle out in terms of its speed, and it's going to slow down. All right, so what I just drew for you is what's called a longitudinal profile. That means you're looking at the stream from its highest gradient to its lowest gradient, and you're seeing how that changes over time. And we're going to see how the cross section of the stream is going to change over time as well. So let's say that up at high altitudes right here, you got water charging down the mountainside, right? It's rushing down. All right, well, it's got a lot of energy. It's moving fast. All right, and so how is that going to create a different channel than it is if it's moving pretty slow? Well, the next slide here. So, right here, this is, we might say, a cross-section taken from somewhere high up in the mountains right there, okay, where the water is still rushing downhill at a pretty steep slope. And as it rushes down, it really carves out a pretty deep groove right here. So all these dots I'm drawing right here is the water kind of rushing towards us. All right, that's why we call this a cross-section. It's kind of like you went in the middle of the stream. Let me redraw that there. You went in the middle of the stream, and you're kind of looking at the stream in kind of a cross-section. All right, so it's cutting down a pretty deep groove into the land right there because it's moving fast. But look what happens right here. Let me change to a different color. I'll change to red. So right there, it's close to the coast. It's probably pretty flat. It's still sloping, but not as much. There's less of a gradient. And so what happens is, right here, the river kind of spreads out, all right, and just sort of takes its time, and I'll try to draw water in right there. It fills up a wider area. It doesn't carve as deep of a groove, but it spreads out pretty wide, and so you've got a wider river. This is very much like I just drew a minute ago. This is called the longitudinal profile, like the sideways view from the side of how it goes from steep to being fairly shallow. All right, so what causes rivers to get carved out by moving water? Well, water itself does have a certain amount of force, but also there's stuff suspended in the water. The water itself carries stuff along with it. So as the water is moving downhill, yes, it itself can carve stuff, but we also have things like what's called the bed load. All right, and so I'm drawing some little rocks here. Actually, I should draw the bottom of the water. All right, some rocks that are moving along the bottom of the stream as it moves downhill. Okay, these rocks are kind of bouncing along as they bash into each other. They break into smaller pieces, but they also carve out the riverbed as well. So we call this the bed load, as it kind of scrapes out the bottom of the river and makes it deeper over time. It's also something called the suspended load. Okay, and the suspended load means that this is lighter stuff, lighter silt and sand and all kinds of little particles that are just kind of in the water, but normally they would sink to the bottom, but since the water is moving, they kind of get stirred up, and they're suspended in the middle of the water right there. All right, so this is carried downstream as well, especially at the faster the water moves. Finally, there's also dissolved load. This really doesn't do a whole lot, but it's in terms of carving out rivers, but it's chemicals. It's things that are dissolved in the water, like say salt, for example. Salt's a good is an example of something that gets dissolved easily. So these are all materials that are carried down a river as a result of the river's energy. All right. So we didn't talk about the rock cycle, but you probably know that rocks are recycled. And go through various different stages. Well, rivers play a big part in that. Right? What they do is they carry these particles, the suspended load, the bed load, the dissolved load, downstream and deposit them somewhere else. All right. So, depending on how fast the river is moving, or you might say the stream velocity, that will determine how much erosion takes place. Yes, the faster the water moves, absolutely, it's going to erode the riverbanks more. What happens if water, so that's got a really, we'll say it's a high velocity right there, okay? What if we have kind of a less of a velocity? What's going to happen? All right, well, as high velocity rivers carry particles downstream, what less velocity rivers do, or slower rivers do, is they allow particles to settle to the bottom. Because remember, suspended particles don't actually float, but they're just carried along with the water movement. If the water slows down, they're going to settle to the bottom. And so that's one big part in the rock cycle, the settling down of all these particles right here. So this brings us to the idea of what's called discharge. Okay, now if you're in the military or something like that, and you get discharged, it means you get sent out, or you get let go. They send you on your way. Well, rivers do the same thing. They have a certain discharge, all right? And so they send the water on its way. And so it's really the volume of water that moves down a river at any point in time, all right? So as we drew just a minute ago, we have, let's do brown right here, all right? We have a river cross-section right there, okay? And there's water flowing through it. Like that. So this right here would be the cross section of the river. That's an area. All right, but as it moves out towards us, in, let's see, I don't know, like that, then that means this whole chunk of water from there to there, I'm trying to draw like a three-dimensional thing right here. That's a volume of water. All right, it's got a cross section and also some length as well. So over some period of time, the river is going to, depending on its discharge, is going to send out a certain chunk of water downstream. All right, so the slower the river, the less the discharge, the faster the river, the higher the discharge. All right. So here's a good cross section of a river right here. All right, so the area. There's the area right there. The cross-sectional area of the stream. We take that and we multiply it by, what was this arrow that I drew a minute ago? That's really the velocity. Okay. And the velocity is some distance per second, right? So, I don't know, meters per second. So if we got an area times another unit of length, all right, over some period of time, that will give us our discharge. So we're kind of like creating a three-dimensional volume or a chunk of water that is sent downstream over time. All right. So as moving water moves particles downstream, those particles can take various different shapes. Right here, this is Death Valley. Right here, you wouldn't think of there being any streams in Death Valley, but water does move. And as you can see in between these mountain ridges right here, you've got what's called an alluvial fan. Now, alluvium is something we're going to talk about a little bit later. That just means all the suspended stuff that's in the water, the particles and the silt and stuff. But this stuff got washed down the valley and is kind of spreading out into a fan on the Death Valley floor. All right, over on the right-hand side looks like, well, something that involves more water. And this is the Mississippi River Delta. All right, the reason there's a delta is because all these particles and sediment and silt and stuff are deposited on either sides of the river as it moves out. And so this big kind of bird's foot shaped thing right there is really particles that have been deposited over a period of time. So if you know anything about the Mississippi River, you may notice that it doesn't really exactly flow in a straight line. It has a tendency to have a pattern which is called meandering. All right, what meandering means is, well, if a person meanders, it means that person just kind of wanders back and forth and doesn't have any real direct purpose to their walk. Well, rivers do the same thing. All right, they can, instead of flowing straight downstream like that, they can start to kind of wander and develop sort of a back and forth pattern right there. So as the river moves, as it moves around a little bit of a curve, it moves faster around the outside. Oh, that's a terrible arrow, sorry. And it moves faster around this side right here. And so really what it does is it cuts out, it makes the river wider. I'm sorry, not wider, it makes the curve wider and wider, so it meanders more and more. So the more it meanders, the more it meanders. All right, and so as this river cuts back and forth, if it creates this whole area where, so between here and here, this river is meandering back and forth. So that whole area in between the meanders is called the floodplain. Every now and then, even though it's meandering back and forth and the water is staying in that channel right there, if it gets too much water or there's too much discharge, it overflows, and so it spills out all onto this whole area right here. Sorry, I'm drawing all over our notes right here. But we call that a floodplain because that's the flat area along which the river floods out onto, which discharge and can't handle it all. All right, here's a good example right here. River channel and the floodplain that surrounds it. All right, so floodplain. It's a flat area that floods. It's pretty easily described. Right? You know how I was saying a minute ago how a river tends to meander and tends to make its curves wider and wider? Well, there's a reason for that. Remember I said before how as it goes around curves, it moves faster to the outside. Like that. All right, and like that. And so along the outside is where it does the most cutting. And so these curves get curvier and curvier over time. And so if it moves faster on the outside, that means it must move slower on the inside. That's definitely true too. So right there and right there, it's moving slower on the inside of that curve. Well, remember we said before that as water moves slower, it tends to deposit suspended particles because it can't carry them anymore. And so we see these banks, they're called point bars, or just think of them as like sandbars, that are deposited on the inside of curves right here. And so again, it makes that curve curvier and curvier over time. Here's another example right here. Another good diagram of that, how on the outside, the river's moving a lot faster, or maybe not a lot faster, but considerably faster. And on the inside, it's moving definitely slower. So it's going to deposit all that stuff. So we've got kind of this sandbar right there, and on the outside is where it's really cutting out further and further. All right, now the other kind of pattern, aside from a meandering pattern, is called a braided pattern. And you've seen when things are braided, are braided, or if a person's hair is braided, the various different strands are woven back and forth and tend to interlock back and forth, back and forth. Well, that's what happens right here. All right, so you can have, I'll do these in different colors right here. There's red, there's blue, all right, and green as well, all right. So all these different patterns weave back and forth and make what doesn't look like a single river, but lots of different river channels that kind of interlock back and forth, back and forth. We call that braided. Now, over that whole area, over between, let's see, I'll draw this in orange, all right? Between here and here is considered the river, but or the river plain. But in that area, you can have various different braids of water that kind of wiggle back and forth. All right. So, ideally, we have three different areas within a river. All right. Now, no river is perfect, and this is why we call it the idealized model right here. But we've got three main zones. All right. The first zone is where water is picked up. I'm sorry, not water. Where water is, I should say, it starts flowing. Okay. Not only that, but as the water starts flowing, it starts to pick up other things, like sediment and gravel and sand and stuff like that. So it's really where the water starts flowing and where the various suspended loads and bed loads start moving. All right. The second zone is kind of like, you can think of it as sort of like a conveyor belt. All right, where it's transported. So the water starts flowing from, we'll say, runoff. All right, water starts flowing from runoff somewhere upstream. It starts to carry things downstream, and now we have that distance over which it's carried. This is our zone 2 right here. It's moved downhill. So a lot of times you can have sediment dropped off. Maybe other sediment is picked up along here. So there's sediment that is exchanged. But this is kind of like the transport zone right here, where it's moved from point A to point B. Finally, zone 3. The last zone is where everything is pretty much dropped off. All right, water slows, and it's very close to what was called base level. Now, base level is basically, the ocean. You can't get any lower than the ocean. So as it moves down and gets very close to the ocean level, it starts to get very, very flat, and the water slows down. So all these particles start to drop out. So this is our third stage right here. So you can have stuff being deposited like in a river delta, or in what's called, like I said before, an alluvial fan. All right. So these are things where all this, these are features where all this sediment is built up because it's being dropped off, because the water's slowing down. All right. So this is kind of, like I said before, kind of an oversimplified model of the river system. All right. You got our first zone up here, way high in the mountains. Okay. Water's charging off the land pretty fast because it's steep. And it's starting to pick up individual sediment grains, particles, and sand and stuff like that. All right, the second zone right here is where it's moving. Okay, so it's moving over this area. It kind of covers most space over that area right there. So some sediment is dropped off, like you might have on the inside of sandbars on curves. Other sediment is picked up as the water kind of charges around corners and wears down sediment from the sides of riverbanks right there. So sediment is exchanged, like I said before. And finally, the last zone right here is where it's all deposited. It's put somewhere. And many times you can see that in the form of a delta. Sometimes it's even deposited underwater out to sea. And if you look on the ocean floor, many times you can see massive piles of sediment that have been deposited by large rivers as they move down towards the sea. So that's our idealized diagram of the river system. And in the next section, we're going to be starting to talk about floods and what actually makes floods take place in rivers.